In this course, all of you, welcome to my course. In this course, rather than me telling things to you folks, the way in GrainEd we would like is more of a discussion. If you you should have a lot of questions about engineering. What is engineering? Now, when we say what is engineering, you don't have to go into the theoretical and mathematical and all those kind of things. No, just simply what is engineering. Like if I ask you what is a pen, you know what a pen is, right? Something that can write. So those kind of simple answers to engineering questions. What is engineering? Why engineering? And how do engineers do their job? The hows and whys and in simple terms. We are not going to go into the as I said, very theoretical or very mathematical kind of models. No, but it's going to be very simple for all of us. And then I want you guys to ask me questions and try and understand things. That should be the way you should think. And every one of you should be asking those questions. So prepare your questions. We'll go through some slides, but then it doesn't matter. So as Satish said, I am an engineer. I work at Exxon Mobil Corporation as I'm an engineer and scientist because I work in research. So and then here is the book Satish was mentioning, Spirit of Engineering is the book I wrote. Before we move forward, I would like each of you to introduce, just can you introduce what grade you are in and how are you doing today? And are you currently considering engineering to be your career? Some of you are, some of you are not, some of you don't know. That's fine. That's very fine. And then one thing you want to learn from this course.
Okay, so I am in 11th now. I consider engineering as a viable career option. I would like to know about the exams we have to take, then different aspects in engineering and the colleges.
Yes, so my name is Nived. I'm studying in I'm studying in class 12. I'm doing good. And yes, I am considering engineering as my career option. And what I want to learn from is this, from this course is the various career options available associated with engineering. Like I've heard there's far beyond this mechanical, civil, and this common thing.
Good evening, sir. Yeah, I'm doing great, and I'm a student of grade 12. And yes, I'm considering engineering for a career opportunity. So the basic thing I want to learn from this course is the prerequisite skills required for engineering. And once we enter this field, what do we expect? What do we expect to learn and other career opportunities?
Good evening, sir. My name is Shivani, and I'm currently studying in 12th grade. And I do consider engineering as a career option, but I'm also kind of confused to go for pure sciences as well. So from this course, I want to get a little more clearer idea about what to go for next.
Okay, so I'm so happy to hear all these your introductions, because most of you are considering engineering as your career. That's great. Being an engineer, I want more people to take up engineering. And that's just my passion. But then more than that, we'll talk about it. And then you folks want to know a lot of things about engineering that exactly I wanted to cover. Like, what's the difference between science and engineering? What do engineers do at their job? What are the career options? What kind of colleges? What kind of courses? All sorts of things, right? And then this is exactly I wanted to cover in this course. So what I will do is maybe one of the sessions we can devote only to the career options. Maybe the fourth session can be just about the career. Let's try and understand what engineering is, a little bit of basics, and we can discuss what engineering is, and maybe you might have a lot of questions as we go. And then in the end, in the last session, we can just talk about the career options and what's happening in the world. You know, the world is changing so fast, and you know, if you talk about artificial intelligence is going to take over a significant amount of jobs and things like that. So how we can not just cope with it, how you can excel in a world that is changing every day, right? That should be your thought process. Okay, the world is changing, so what? So how do I navigate this ever-changing world, and how can I make use of the changes? How can I prepare myself to embrace the changes than resisting the changes, right? It's always hard to swim upstream, but if you want to take advantage of the flow, what are the skills I need? How do I prepare myself? Those are the questions, being young folks, you should be asking. You know, Satish and I are, or Tessie teacher, we are all in you know, way, you know, older than you guys, and we are way into our later careers. You folks, you know, it's going to be, everything is going to be new, and everything is going to be changing very fast. So that's the kind of attitude you need to have. I will talk about those things later, not today. In one of the classes, I will talk about the changes and how we can navigate. What are the kind of skills and, you know, stuff we need to work on. So definitely, that's excellent. So it's, you know, it's very important to know what you guys want to know, right? I mean, and from my perspective, as Satish said, I always had a lot of opportunities to interact with young folks like you in schools. I have taught a course in an engineering college, a full course I have taught, and then I have taught other students in when I was doing my PhD, I taught some students. So I have been in touch with a lot of young engineers, students, and then in my company also, we have all sorts of people from very young engineers to very old engineers, right? So we get to interact with all age groups of engineers. So even today we have a fresh engineer. I mean, who's actually, we have an intern from MIT. He just completed 2 years. So, you know, he's in college. So I get to interact with those folks also. So from all these interactions, I have learned a lot of things. I have understood a lot of things. That's why I really want to do this course. And that's why it's important for me to understand what you guys think about what you really want. So this introduction has been great. I really love it. Most of you want to take up engineering, so that's great. Any questions before we move on?
No, sir.
All right. So let's look at why this course and what this course is. You know, as I said, when I interacted with a lot of young engineers, one thing I understood was that a lot of students grapple with the question, why do we learn so much math and science in engineering? You know, engineers have to learn a lot of math and science. So, but then many students didn't appreciate, why do we have to learn so much math and science? So I'm going to address that question here. You know, maybe many of you think that way too, right? How many of you want to know why a lot of math and science is involved in engineering? That's my experience. A lot of students really wanted to understand that, the answer to that question, why a lot of math and science? And then a lot of students in a college of engineering or many college of engineering, I have seen they struggle to connect the engineering subjects to practical things. You know, say for example, I'm studying control theory, I'm studying thermodynamics, I'm studying mechanics, all sorts of things. But where do we connect these you know, these subjects with a real world problem? A lot of students don't really get it. you need to get that. If you don't get that, you cannot be a good engineer. You can pass exams, but then passing exam, nobody cares. In my company, when we design things, when we run experiments, when we design products, nobody asks me, did you pass an exam? My boss is only worried about how good the product I am designing is. That's the only thing he cares about. Nothing. Whether I passed exams, he doesn't even know. He doesn't care. Nobody cares. And look at the customer. If you're buying something, you're buying a washing machine. What you care about is the performance of that washing machine, right? Nobody cares about if this engineer had 98 or 73 marks in his engineering. Nobody cares. What you care about is the performance of the product an engineer designed. So that's where an engineer's capabilities, right? So how to connect, engineering subjects to practical things, that's very important. So, and then in India, this is a real big problem. We have huge supply of engineers, right? I think, 700,000 engineers or something like that every year, passing out of colleges. But most of them are not employable. I'm not saying this. If you read report after report after report, you can see most of our engineers are not employable, which is terrible, right? Because we engineers are professionals. Professionals, okay, let me ask you, what's the difference between a professional and an amateur? Can anyone unmute and say?
Sir, the professional has a lot of experience with one thing, and the amateur has like less experience.
Good answer. Keshav, any other answers, please?
So a professional has a lot of knowledge in particular problems, but while an amateur is not so sure, it's like lower than a professional. A professional has more knowledge than an amateur.
Yes, that's a good answer. Right.
An experienced engineer will know more, like what to do in each scenarios, whereas an amateur won't have the knowledge. Like he will get tensed real fast about a few situations if you don't know what to do in that.
Yeah, good answer. Yeah, you all might know a lot of answers to these questions. What's a professional is? What's an amateur is? Actually, an engineer is a professional. First of all, that's one very important thing to know. An engineer is a professional. Now, let me give you an example. What's the difference between me playing cricket and Virat Kohli playing cricket? Okay, let's remove the fact that he's incredibly talented, but just look at the fact that he's a professional and I'm an amateur, right? If I play cricket, most of the time I just play cricket to enjoy that game, just for the sake of it, right? I'm playing cricket just to play cricket. But when Kohli plays, he's not playing cricket, oh, let me go and enjoy cricket. That's not he's doing actually. He's a professional. The first and foremost thing is he gets paid to play cricket, right? A professional gets paid to do something. So there's a job to do and the professional gets that done and he or she gets paid, right? So that's the difference. If you're an engineer, you have a big responsibility because you get a job to do and you get paid for that particular job. That's very important. So if you're a professional, that's it. Now, what are the qualities of a professional? A professional must have some qualities, right? Otherwise, why will somebody pay you? Nobody pays me to play cricket, right? No one, unfortunately. I would love, but unfortunately, nobody pays me to play cricket. Why do we pay somebody to do a job? Because a professional has the skill set. Note the word skill set. A professional has certain very, very unique kind of skill sets a professional does, right? Like Virat Kohli has great skill sets to play cricket. That's why he's paid. And then how does that professional do that job? He or she practices, gets a lot of experience, as you said, a lot of experience and expertise. You know, experience doing things, experience, and then expertise, you know, how to do things, learn, and then expertise. You develop those kind of expertise. So these are the keywords about a professional, right? Can anyone repeat some of the keywords I used here?
Expertise and experience.
Yeah, correct. Any other? I use the word skill set, right? Skill set, that's important. You improve your skill sets. In a college of engineering, what are you doing? In a college of engineering, they teach you a lot of skills, actually. Those skill sets, they may not be perfect. You perfect those skill sets on the job. But this is why you are called an engineer, because an engineer has certain skill sets. Now, we'll talk about those skill sets, definitely. So this is what you need to know fundamentally. If you're going to be an engineer, you are a professional, you should have those skill sets, you should have some expertise, and then you gain experience, and then you deliver on a particular job. That's why you get paid. It's not charity, right? Nobody wants, oh, okay, this guy's an engineer, let me pay him. No, that doesn't happen, unfortunately. If somebody pays you $1, they really want something to get done, right? So that's the first and foremost thing. Okay, so yeah, see, this is kind of an open-ended discussion. So I might go, you know, in complete tangents and come back sometimes. You can do the same too, right? I don't mind if you went completely, you know, in a tangent. And the only thing is we need to come back to engineering. That's the only rule. Otherwise, it's open for all. So. Okay, so we talked about professionalism and professional. Any questions? Okay, I talked about professionalism basically because, you know, many of our engineering graduates are not very employable. No, we want to make them employable. If you guys take up engineering career, I want you to be great engineers, wonderful engineers, and very employable. An employer should be happy that, oh, I'm happy that I hired this guy or this girl, you know, they're doing wonderful. That's what I want you guys to be tomorrow. And if you don't take up engineering career, that's perfectly fine too. Everybody need not be an engineer, right? There are so many different professions, different jobs. We are all different as humans. We have, you know, multiple talents. So you can be whatever you want. But then if you're taking up an engineer, I want you to be very employable. So that's why I want you to be very professional. And coming to you folks, you know, many high school students want to pursue career in engineering, but do not know what it takes. What it takes to be an engineer, and what do they have the aptitude? Do you guys have the aptitude to do this? So that's important too. Honestly, when I went to engineering, I really love science and things like that, but I didn't really know what engineering is. That's very honest, you know, confession. I didn't know, but I always, you know, wish I did those days. I didn't, but somehow I always liked science and engineering, so I did okay. I'm doing well, actually. So that's an introduction to the course. So this is my book. You know, I'm explaining most of your questions and answers in this book through the story. It's a story, so it's very easy to read. Whenever you get leisure time, just read the book. You know, you can get a lot of answers through, you know, Matt and Maya, two kids are, you know, first year engineering students, story and their travel and all sorts of things. So I highly encourage you folks to read the book. The course objectives, actually, we talked about, to learn the basic concepts of engineering in simple terms. We'll just touch upon basic concepts of engineering, and then we'll address, I'll talk about the 4 pillars of engineering. Then it's easy for you to remember, once you know the 4 pillars, it will be easy for you to remember what engineering is. Instead of, you can read all sorts of, definitions and things like that. But then if you just remember the 4 pillars, it's easy for you to appreciate what engineering is. So I'll touch upon the 4 pillars of engineering. And then a little bit of, understand engineering education. And then, you guys, you folks can really determine whether you want to be an engineer, what you really want to be. So any questions, concerns about the objectives? Do you want anything else? Feel free. I'm completely open. This is not like a school class or anything, right? We are more like peers. So very good. I just wanted to touch upon a basic thing is, why engineering? Engineering is around us, right? All around us. So can you guys name something that are engineered, please, in the chat, or you can unmute and say.
So buildings.
Yeah.
Electronics.
Machine.
Yeah. Yeah. Anything else?
Electronics, buildings, machines, robotics,
Yeah.
and the list goes on. Chemicals, all of those.
Yeah. Yeah. Now, can you name some things that are not engineered?
Some like natural things.
Plants,
Like,
animals, land.
yeah.
What was that? I didn't hear. Yeah, I heard natural things. Anything else?
Some medical.
What was that?
Medical resources, like medicines.
Medicines?
So I'm not sure about medicines because I think they might come in chemical engineering.
That's a very interesting, yeah. Yeah, so let's take a step back. You know what? If you take the planet didn't have most of the things that we see today, right? No cities, no transportation, no electricity, no communication, no cell phone. Whatever we see man-made, and pretty much everything you see around pretty much are man-made, right? The house we live in, the clothes we wear. Do you think about the clothes? So much of engineering goes into your clothes, right? From the cotton is farmed. In farming itself, they use a lot of engineering. Let's leave that. Collecting cotton is engineering. You use a lot of machines, and then to transform that cotton into yarns, you need a lot of engineering, milling, and all sorts of weaving technology, and then to again transform that thread into a cloth. Weaving machines, a lot of engineering, and then dyeing, then moving, rolling, and then cutting and making into your cloth. A lot of engineering is required to make your clothes. How about a toothpaste? A lot of engineering goes into the toothpaste itself. And what about the packaging? That plastic. Our company is one of the largest manufacturers of plastic. So huge engineering plants make those plastics. How about the paints, the colors? There are at least 200 engineers involved in making that toothpaste. But we don't appreciate it. And anything and everything you see, look at your car, your bus, the train, anything, transportation, the whole thing, completely engineered, right? So the point is, engineering is everywhere. The quality of our life has been improved by science and engineering for the last 300 years, right? I'll talk about it in another session. The transformation from maybe last 2,000 years to the industrial revolution and scientific revolution, and how things change. And I'll talk about it maybe in the next class or the class after. So everything is engineered around us. So the important thing is we need a lot of engineers to run the world the way it is and to move the world forward, right? World doesn't stay stagnant. It's very dynamic. Our life is dynamic. Our society is dynamic. Industry, everything is dynamic, right? And to move everything forward, we need a lot of engineers. So engineering is a great career because we always need engineers. Yeah, now I have a question. So what do you think an engineer did at work?
So develop something.
Yeah, develop. When you say something, can you be a little more specific?
I don't know, maybe like a plan for a building, or
yeah,
something like an app.
Good. What else engineers did?
So the day-to-day products that we use, like basically everything that the human revolution has come to know, all the things that we used to do till date.
Yes, good.
So making our life more sophisticated and easier by building gadgets.
Yes, I would say improving the quality of life, right? Many years ago,
That's what I meant.
We didn't have electricity, right? And we engineered electricity. We controlled electricity. Electricity was always here on the planet, right? Lightning and chemicals, or electricity was always there on the planet. We actually tamed electricity, and we can control electricity. We can distribute electricity. We can build gadgets. Today, life without electricity is kind of impossible, right? We can't even imagine. And that changed our life. We don't have to go bring water from a well. We can pump water, right? And it comes right to your bathroom or your home. You can use a fan. You can use air conditioning. You can use a washing machine. You can use all sorts of things. Even we are talking on a computer that uses electricity, right? So as an example, electricity changed the world to a level that's kind of unbelievable for an 18th century or a 19th century person. They wouldn't even recognize the world today. So much changes. So engineering, basically what we do is we improve the quality of life. Now, how do we do it? I will talk about it more in the career options. Engineers design and develop and build and operate, things that improves our quality of life. We design, we develop, we build them, and then we operate them too. So that's what we do. In my job, I have worked in operations, operating plants and things like that. I have worked in design. I have worked in design and development, and then I have worked in, as I said, operations. Now, currently, I work in research. In research, actually, we don't do any fundamental research. Our research is product development. We develop new products. So we design and develop new products. That's what we do right now. So, and many of my colleagues do process development and all sorts of things. So that's what we do at work. So we design, we develop products and processes. We'll talk about processes. Products and processes, we develop and design and develop, and then we build, we manufacture stuff, and we operate, plans and processes, all sorts of things. That's what we do at work. We'll talk about them more. Any questions? Then we'll talk about how do someone become an engineer, of course. Before we close today, we'll talk about a very generic kind of definition of engineering. Okay, so let's. Okay, what is engineering? Can you define what engineering is?
So using mathematics to solve problems or build infrastructure.
Very good. Actually, in this course, I will talk about what's the difference between a mathematician and an engineer, or a physicist and an engineer, or a technician and engineer. These are all a little, if you look at those definitions are a little nebulous, right? But then I will try and bring some clarity as to what is the difference between an engineer and a physicist, and an engineer and a mathematician. So, you can count on that. In the coming class, we'll talk about those. So, okay, what's engineering? Any other answer?
Sir, it's the field of study that helps the humans utilize the things from nature and make a lease of life.
Very good. Excellent answer. Yeah. Excellent.
Rishikesh writes application of science in chat.
Yeah, very good. Yeah, application of science. Yes. Now let's look at very standard definitions, of course, from Cambridge Dictionary. You can read it, but yeah, the study of using scientific principles. You know what? It's very important to know we use scientific principles in engineering to design and build machines, structures, other things, including bridges, roads, vehicles, and buildings. I would add, we build a lot of processes also. Being a chemical engineer, we design a lot of processes. It's not just a product. So we use, when you design, we talked about why a lot of math and science, and why do we learn math and science? Because we use math and science to design and build things, right? The scientific principles. We don't use our gut feeling. We don't use a heresy. We don't. Oh, somebody told me this will work. That's not the way you design something, right? You design something based on solid scientific principles. When you design a dam, you have to calculate all the forces on the dam, right? The hydrostatic pressure, the seismic effects. Even if it's going to be windy, you have to take the wind loads or whatever. All sorts of forces. And then you design a dam, right? Or a bridge. When you design a bridge, basically what you do is you understand all the forces acting on that bridge, and then using strength of material, you can design and build that bridge. So we use solid scientific principles, math and science, to calculate the loads, all sorts of things, and to build, design and build things. So that's one definition. It's a very simple and very kind of easy to understand kind of definition. But then I would like the Merriam. Oh, come on, what happened? Oh yeah, the Merriam-Webster definition is much more fundamental. I'll tell you why this is more fundamental. The application of science and mathematics, again, the scientific principles by which the properties of matter and the sources of energy in nature are made useful to people. Every word is very significant in this definition. It's a beautiful definition, actually. Think about it. Think about it. What is available to us in the world? What on the planet? What is available to us, being humans? What is available for us in the planet?
Natural resources.
Yeah, natural resources. What are they fundamentally? If you look at only two fundamental entities, right? Matter and energy. That's all. When you said natural resources, You can classify anything. You take any natural resource, it's either matter or it's energy, right? Those are the two things available to you. And being engineers, we use matter and energy. We make them useful to people. Coal and petroleum were here on the planet. Petrol, for example, let's take petroleum. Petroleum was here on the planet for millions of years, right? And none of the species, maybe there might have been 20 million different species, right? Currently, maybe 9 million species on the planet. We are the only species that uses petroleum, right? So petroleum is a resource, petroleum is matter, and we can convert that matter into energy. So we have matter, and for example, iron ore. You have plenty of iron ore on the planet. No other species ever used iron ore. We use iron ore and we purify iron ore and get iron, and we build a whole entire world with steel, right? So we use matter and energy to improve the quality of our life. We build homes using matter and energy. We run an automobile using matter and energy, right? We produce food using matter and energy. So using matter and sources of energy, when it's a source of energy, there are many different sources of energy, right? Okay. So that's a fundamental definition. If you understand this, it's beautiful, actually. Humans have only two things on the planet, matter and energy, and you can use these two to improve the quality of our life. That's engineering. That's engineering, actually. Questions, comments?
So, the study of the matter and the energy is called sciences.
Yeah, that's a difference. If you in science, what you're doing is, if you're a physicist or a chemist, what you're trying to do is you're trying to understand how things work or why things work. That's a scientist's job. You're trying to understand why oxygen reacts with hydrogen and produce water, or how oxygen reacts with hydrogen and produce water. But if you are an engineer, that's not your concern. Your concern is use that matter and energy to build a product or build a process that helps humans improve their quality of life. So being engineers, we always look at how I can build stuff. I can build processes and things like that to improve the quality of life. I'm not really worried about how things work or why things work. I can give you a lot of examples. When Wright brothers, they were great engineers. When they built an airplane, actually we didn't know why, if you camber the wings, why you get that lift. We didn't know, actually. But scientists later discovered, exactly the Bernoulli's principle and what happens exactly to airfoils when you have a cambering, the airflow and aerodynamics, how the pressure decreases if you have a cambering above, and how the pressure increases. Those things we know, we discovered later. But many things engineers use, we didn't even know why those things work, actually. And when we used when people designed when Otto designed a spark ignition engine, petrol engine, we didn't really understand how petrol burns and how exactly the combustion and the pressure increase, those things take place. We didn't know the exact nitty-gritties of those things, but he designed an engine, that engine worked, right? And then Carl Benz designed a car too. So we didn't understand a lot of things, but engineers are not trying to understand the world. That's not engineer's job. That's a scientist's job. To understand the world, it's a scientist's job. An engineer's job is to build things that never was, right? Theodore von Karman said, scientists always discover an existing world, a world that always there was, but engineers build a world that never was. So that's our focus. Build a new world that never was. Right? There was no bridge on this planet, or there was no home, there was no car, there was no plane. We built all those. So that's the difference here. Exactly. Any other questions? Good question.
Okay, sir.
I think we are over our time commitment today. So yeah, any more questions? You can ask any questions. I'm open to any question. It doesn't have to be engineering.
So may I ask a question?
Oh, sure. Go ahead.
So, like as you said that that an engineer doesn't need to understand how, like we don't need to go in details with a particular subject or with a particular material or any any topic. But sir, like if as an engineer, if I would be an engineer. If an engineer was not supposed to think about or was not supposed to research on things, then sir, we would have made a lot of things with wood as a fuel. But we are using petrol and diesel instead of wood. So sir, how would you like describe a lot of things on that on basis like an engineer also needs to like think on these things, or it's like what the scientists provide us, we have to work on that?
That's an excellent question. Actually, when I say I don't say that you don't need to understand things. You need to understand how things work and why things work, about the materials that you're using, the energy that you're using. But then what I'm saying is you need to understand to the level you can design things. You don't have to understand the fundamental. My point is your goal is not to understand things. You understand things so that you can use it. For example, simple example I can take is language, right? You speak English,
Yes.
you write English,
Yeah.
You learn English to use English, right? But you are not a linguist, are you?
No.
That's exactly it is. A linguist try to understand the nuances of the language and where did the language come from? Where did the word come from? Where the word is going tomorrow? How can I coin a new word? A linguist is working on the language to more and more in-depth understanding and improve the language itself. But you and me learn a language to use it, right? And if you know that language very well, you can use it. If you don't, you cannot. That's exactly what engineers do. Engineers try and understand science. You need to understand thermodynamics if you have to design an engine. You need to understand electricity and really well if you have to be an electrical engineer. You need to understand things, but then your goal is not to understand that. Your goal is use that and design something that is useful. That's the point I would like to make. You're exactly right. And a lot of engineers have discovered a lot of fundamental things, definitely, a lot of fundamental things. But then that's not your real goal. Your goal is to use that thing and design a product.
Okay, sir. Thank you.
Did I answer your question?
Yes, sir. Thank you so much.
Right.
Sir,
Yep.
I've heard about some cars using unusual types of fuel, for example, water. So how water and hydrogen, and about that water, I learned that they're actually taking electricity to separate the oxygen from the hydrogen molecules, and then use that hydrogen to power the engine, and the oxygen is removed from the car. Well, how much electricity is used to actually to actually separate those atoms?
I don't know how much electricity is used to do the electrolysis of water. You can just Google and find out, or we can calculate how much electricity is required, but not on top of my head, I cannot calculate it, but then I'm pretty sure it's easy to calculate how much electricity is required to electrolyze water. So you know what? There are two different technologies used using hydrogen. You can burn hydrogen in a combustion engine. Some of my friends have done that. Some of my colleagues have done that. You can burn hydrogen. Hydrogen is a great fuel. Just burn hydrogen in a combustion engine, and you can run just like a petrol engine. It's possible. The second technology used is you can use a fuel cell. Have you heard of a fuel cell?
Yes, sir, I've heard.
You can use a fuel cell where you can use hydrogen, and then you can get electricity from that fuel cell.
And then we can and then we can use that to power the motors.
Exactly. Yes. So these are the two ways you can run a car using hydrogen. Yeah, that's a tangent, but
okay,
that's okay.
Sir.
You guys can ask me anything. If I know, I will answer. If I don't, I can find a person who knows the answer.
Sir? Well, in short, so can we say that engineer is a person who studies science and applies science with the help of mathematics?
Exactly. Yeah. Engineer is someone who uses math and science to develop, design, develop, and manufacture and operate stuff. Yes, exactly. We use math and science. Okay. That's the point. We use math and science. That's always the point.
Okay, sir.
Any other questions? Yeah, we'll as I said, we'll cover a few more things in detail in our next classes. I will leave one full hour for the career things. You know, so we should go into a little more detail in the next class. I'll talk about the 4 pillars of engineering and what is engineering a little more, and then we can talk about all these, you know, changing world and career and what you can do about it, those kind of things. Before you go, I want you guys to do 2 exercises, very simple exercises. Are you ready? Not for the next class. I want you to do a little bit of homework. Very simple homework.
Okay, sir. Okay, sir.
Yeah. One is just watch a video which is less than 10 minutes about engineering, and just tell me what you watched and what you learned from that video. Just, you can watch any video about engineering. Tons of videos are available. I didn't want you to watch one video because I want you guys to have multiple different videos and, you know, and see, and let me know. In the class, you just tell me what you watched and what you learned from that video. Everybody good with that? Okay, that's first assignment. The second assignment, it takes you 10 minutes, right? Or maybe to search another 10 minutes. Don't spend more than half an hour, okay? Now, another thing is just choose a product of your liking. Just choose anything that you use or you see in around you. That's an engineered product, and just think about what if an engineer designed it. What did he or she think about when they designed? What were the design parameters? You know, they might have used a particular, a set of design parameters, right? For example, if I can take a car, you know, when you design a car, am I designing a mid-size sedan or an SUV? The size of the car, the power of the engine or an electric motor, and then, you know, what kind of speed, what kind of ground clearance, all sorts of parameters are important in designing a car, right? So you can choose anything. It can be very simple product.
Speaking about that, I have saved some car drawings and car sketches that I actually want to email to car manufacturers to see what they think about it, and if they like it, if they like it that much, put it on the market.
Very good. So so your second assignment is to select one engineered product and think about what are the design parameters used in that product. I know you are not engineers, so you don't have to spend a lot of time. Just think about it for 10-15 minutes and just note down what should be the design parameters. That's all. These are the two assignments for you folks. Please do this, and we will meet next Sunday, and we should have a blast. You folks are really awesome. I like the questions and I like the enthusiasm here. Wonderful. So all the best, and let's meet next week.